Hi there, this is Dan Reinman with Reinman Cues. I've got another video to share with you as I record and document the machining process as I work towards consistent, repeatable results. Today I'm cutting a flat bottom inlay on the Cue Demon, designed and manufactured by Chris Walker of Billiards Innovations. This is a traditional solid inlay process, so unlike epoxy fill work, accuracy and fit are critical from start to finish. This inlay uses a flat bottom pocket and a matching solid inlay, what I'll call the female and male parts. There's no epoxy doing the work here to fill in the nooks and crannies. The fit and the depth consistency, wall quality are what determine how clean the final result is going to be. So that means everything from the CAD programming to the cutting order, everything has to be intentional. So I created both the pocket and inlay toolpaths in Vectric Aspire. First, I generated the toolpath for the male inlay, and then I generated a corresponding toolpath for the female pocket, making sure both share the same geometry and reference points. Once the toolpaths are finalized, I export the separate G-code files for the inlay and the pocket. Okay, so first things first here on getting everything set up and lined up. I'll be using this little piece of Billara wood here, and let's see how thick that is. I'm looking at about 151 thousandths. I set up the toolpath to carve out 155 thousandths, so this should just barely go through, but not go through the tape. Might leave just a little hair, but it should pop out even if it doesn't go quite all the way through. It should be really close. But we've got to attach this to our spoil board here. The way that we do that is put a piece of tape on the spoil board, piece of tape on the inlay material that we're cutting up. So don't need to go the whole way down here. I'll just put a small piece of tape here on the end because we're just going to cut out one inlay to show this example, and I'm going to put it into this just scrap dowel piece of wood here. Try to make your pieces of tape the same size. That way when you put your glue on them, you don't miss it and end up gluing your stuff to the spoil board or getting glue on your material. So now I can just take a couple dots, super glue, put it on there. A bit too heavy or it'll smash out. Gonna line up the distance. That's why I kind of draw a little pencil line there. Line up the distance so that you can close that like a door right down onto the product. And then have something, doesn't have to be real heavy, but something, a little bit of weight on it just to sit on there for a couple minutes. Okay, now the inlay material is glued to the surface there, some tape and super glue. I need to pick up the little spot that is going to be the center of my inlay. In this case, I'm just doing a little curved diamond. For example here, it's a 1/2 inch by 1/2 inch curved diamond, and the way that we zero it out, XY, needs to be in the center, and then we'll bring it all the way down and we'll zero the Z out to the material. So I'm just going to pick a little, tiny little dot on there. Probably can't even see that on the camera. That's what we're aiming for. I can see that tiny little dot. If you need to get out your magnifying glass so you can see it, and that's what you need to do sometimes. Most of the time it's not that critical that you get it perfect on whatever you're cutting out. Obviously, whether I cut it on that dot or a little bit to the left or the right, as long as I don't go off the sides of my inlay material, it's going to be just fine. Okay, so now what I do is I can take a piece of paper, put that under there. It kind of does help to have a light behind it, because you can see the shadow of that bit, and you can see that there's a gap in it. And you're going to come down just until you can move the paper left and right, and you can just feel a little bit of scratch, a little bit of drag. You don't want it to be stuck in there, but you want it to be dragging a little bit. You can see I pull it back a little bit. I can see just a little bit of shadow still. And now I'm getting a little scratch, okay? So now I know I'm that close. Then I just take the top of my stepper motor for my Z axis, and I turn that down one click, because each click is about 4 thousandths, which is the same thickness of a piece of paper, right around 4 thousandths. Let me check that again. I should be able to fit the piece of paper under it. A little scratch right there. Down there. Need to go, there we go, counterclockwise with that. So now I'll come over to Mach 3, and I've zeroed out my Z, so I'll hit 0. And I've zeroed my Y and my X. I'm not cutting anything on the 4th axis here, so I really don't care about that. And then I'll load up my G code. Here's my male inlay code. And then I'll run this, it'll position itself. Okay, I've got my G code loaded up. I've got everything zeroed out. I'm gonna run the G code. Brings it to its starting position. Got my coolant running. Start my spindle, let that spin up. Okay. Just pull that up. You can see it. Cut that right out. It's still stuck to the piece of tape. Another good point there, that if it does cut all the way through, you want to make sure that that piece of tape is underneath your inlay, because that could come loose and the bit end up taking a chunk out of the side of your inlay. So you definitely don't want that. There we go. Tiny little inlay is born. Okay. Now I'm going to work on cutting out the female pocket in the material, and I'll set up the camera to show you that. Okay, so I'm actually going to cut this with two different bits. I'm going to cut it with a 15 thousandths size end mill and a 31 thousandths size end mill. Okay, so that's the first pass with the 15 thousandths end mill bit, and now we're going to take this out and we'll put 31 thousandths end mill bit in. So I've loaded my program that takes out the material from the middle. This one should run a whole lot faster. It's a bigger bit, it can run a higher speed, and also takes out more material. And then lastly, you may sand the bottom of your inlay, remove any burrs that might be on it, and then glue your inlay depending on the size. If it's a big one, you may use epoxy. If it's smaller ones, you can use CA glue. Depends on the timing, really. So that's my current process for cutting and fitting a flat bottom solid inlay on the Cue Demon. This machine gives me the precision I need, but of course the end result still comes down to careful setup, preparation, and paying attention to each and every step. So thanks for watching, and we'll see you again soon.